Alright, so more solutions to our chapter review. Um, what we're going to do now is, okay, sequence of line reflections over parallel lines. Okay, so what we're going to do is we're going to find its image, A prime. It's 2 away from the mirror. Keep going 2, that's perpendicular. All the rules fit here. 1, 2, 3, 1, 2, 3. Okay, there's B prime. And it says state the coordinates. Let's see if, yeah, okay, they put those underneath. So let me go down and get those. A prime looks to be 1, 3. B prime looks to be 5, 4. Okay. There's then we're going to do the next line reflection for a double prime. The sequence kind of says, okay, go from the image and continue. Don't go back to the pre-image. So from A prime, it's 2 away from y equals 5. And then go another 2, and there's a double prime. Okay. Yeah. Okay, they did tell us y equals 1 first. Just wanted to double check that. All right. B is 1 away from the mirror. Go up 1. B double prime right there. That is 1, 7 for a double prime. And B double prime is 5, 6, it looks like. Okay. Then, so that's the coordinates. Use your straight edge and connect them. All right, that's finishing off the graph. What single transformation has occurred? A double line reflection. So you know that if we had a figure of 3 points, the orientation would be preserved. So it's not a line reflection. Okay. We know 2 line reflections result in one of 2 things, either a rotation or a translation. Now, in this case, here's what you look at. Okay. To me, it looks like this was a translation. It just slid up. Okay, so we'll get rid of that one. We'll get rid of rotation. It's definitely going to be translation. Okay, you can see it just slid in the up direction. Now, we've gone over this. One of my other videos shows what it is. The translation vector is going to be perpendicular to the parallel lines. Okay, so that's going to be important. Write the rule for this transformation. So you could do it this way. You could translate, and what's interesting is it's going to be double the distance between these lines. The distance between these lines is 4. That translation is going to be 8. It's going to be 8 up, so you could say 0, 8. Some people put it in the vector notation, or you could say xy maps to xy plus 8. Okay? So, next one is pretty similar. I think the same thing's going to happen here. Looks like, yeah. So first, what's weird is you're going to reflect over x equals -2. So we're going to head this way. There's B prime. 2 away, there's C prime. Okay. That looks to be -1, 5, and 0, 1. Now we're going to reflect those, but all the way over this. So that's going to be 1, 2, 3, 4, 5. Right there. That's C double prime. That looks like it's 10, 1. 1, 2, 3, 4. 4 away. There's B double prime. Okay, and then that's over at -9, 5. What single transformation has occurred? So what we mean is go from here to here. Again, that's going to be a translation. When we reflect over 2 parallel lines in sequence, then you're going to get a translation. Okay. Now write the rule. It again perpendicular to the 2 lines is the direction that the translation is going to take, and the distance is going to be double this distance here. So if that distance between the two parallel lines is 3, it's going to be a translation 6 units. And it looks like 6 units to the left. Okay, so 6 units to the left, nothing up and down. How we're going to write this is translate, there's two ways. Negative 6, 0. Again, some people don't even use the brackets. And then you could do this notation, x minus 6y. Okay? Any one of those three is acceptable. All right, generalize what happens when a figure is reflected in two parallel lines. We know it's going to result in a translation whose direction is perpendicular to the parallel lines. And whose length or distance is double the distance between the parallel lines. That's always what's going to happen. Check out that investigation that I did on it earlier in the chapter if you want to see that. Some more examples of that. All right, so now we're going to have two intersecting lines. Okay, this is going to be a specific case. You know, there's other cases. You can check out one of the videos that I did earlier in the chapter. So right now we're just going to follow through this. Okay, so we're going to reflect over the x-axis first. So be careful of that. That's probably the only mistake we might run into. C is on the mirror, so C prime going to be the same location. That's an invariant point. Okay, let's make sure we know that term, invariant point. Okay, that's when a point is the same location, pre-image and image, same location. Same exact location. So in other words, the point didn't move. For a line reflection, it means it's on the mirror. Okay, B is going to move 1, 2, 3, 4, 1, 2, 3, 4. Okay, there's B prime. And to finish the graph, really you should connect them with a straight edge. Now we'll go over the y-axis, a double prime. Where was that one? Over -7. And 1, 2, 3, 4, 6. Looks like C double prime's right there. Okay. And we need coordinates. -2, 2. Looks like -7, 4. C prime -6, 0. Oops, sorry about that. A double prime we're looking at is 2, 2. 7, 4, and 6, 0. Good. All right. Now, what single transformation maps the original triangle to its image? This is definitely not going to be a translation. Now, here's how I can tell. A moved, A to A double prime is that length, that distance right there. Okay. If you look at B to B double prime, it's definitely a further distance. So we know it's not a translation anymore. So we check out orientation. I've shown my students this before. A to B is clockwise to C, you know. So if we look at triangle ABC, we got a clockwise orientation. A double prime to B, same orientation. Okay, so same orientation. And so what we know is it's not a line reflection. A single line reflection is not going to do that. So line reflection's out. The other one is translation's out. Point reflection, yeah, you could say that it's a point reflection, but I'm going to use rotation There's a reason. Um, when the lines are not perpendicular, point reflection is not going to work. This is going to be a rotation. Let's go with rotation. How do you recognize it? I went through that. Same orientation. Eliminates. Kind of like I go through and see what's eliminated. So I eliminated line reflection. A to A double prime. This is tricky. Not a lot of students will understand this, but give it a shot here. A to A double prime is a different length than B to B double prime. So translation, they moved a different amount. That's essentially what I'm saying there. So translation is out. Okay? Rotation is all that's left. Rotation is all that it's left for a single, if a single transformation is going to work. Okay? Write out a single rule. All right, so capital R is for rotation, and I'm going to go with, it looks to me like the center of rotation is going to be the origin, and the angle of rotation, believe it or not, is 180 degrees. If you connect B to B, you know, that's a straight path. C to C prime, double prime, that's a straight path. When it's a straight path, it must have been a 180 degree rotation. And I'm going to explain this in a few minutes. You know, the rule that's going to always happen. So I'm going to say 180 degree rotation centered at 0, 0. Now, if you needed the rule algebraically, this is tricky. X, Y maps to negative X, negative Y. Basically, you're going to switch the signs on both. And if you wanted to see that, you could. That did happen. Okay? All right, that's it for this session, and I will take care of the next problem on the next one.